Past year question number 5. The decomposition of hydrogen peroxide is according to the following equation. The rate constant for the decomposition of 2.32 molar hydrogen peroxide is 7.30 times 10 power of negative 4 per second. Plot a graph based on the data in the table below. From the plot, determine the order and half-life of the reaction. Calculate the concentration of hydrogen peroxide at 1600 seconds and the percentage of hydrogen peroxide decomposed up to 1600 seconds. Question B. Both reaction rate and rate constant are temperature dependent. Briefly explain the effect of temperature on the reaction rate by using Maxwell-Boltzmann distribution curve. Let's check how many questions in this essay. Plot a graph based on the data in the table below. Question number 1. Followed by determine the order of the reaction. Question number 2. The third question, half-life of the reaction. Question number 4, calculate the concentration of hydrogen peroxide at 1600 seconds. Question number 5, the percentage of the hydrogen peroxide decomposed up to 1600 seconds. And lastly, briefly explain the effect of the temperature on the reaction rate by using Maxwell-Boltzmann distribution curve. So, there are 6 questions in this essay. Question number 1. Plot a graph based on the data in the table below. Question number 2 and question number 3, from the plot, determine the order and half-life of the reaction. According to the data given, plot graph concentration hydrogen peroxide against time. Then, plot the value when the concentration hydrogen peroxide inertia become half to find out the half-life 1. Then, continue to plot the value when the concentration inertia of hydrogen peroxide become quarter to find out the half-life 2. From the graph, T half 1 equal to T half 2. Therefore, the decomposition of the concentration hydrogen peroxide is a first order. To find out half-life, you need to find average of half-life 1 and 2 from the graph. You will get the value of half-life is 945 seconds. Since we know the order of the reaction is a first order with respect to hydrogen peroxide, so the integrated rate law is ln concentration inertia of hydrogen peroxide minus ln concentration at T of hydrogen peroxide equal to KT. The value of the concentration hydrogen peroxide at T time equal to 0.70 molar. Question number 6. Briefly explain the effect of temperature on reaction rate by using Maxwell-Boltzmann. First, you need to draw the axis X and Y. Y represent number of molecules, while X represent kinetic energy. Then, draw two curves. First, with higher peak represent lower temperature. Second, the lower peak represent higher temperature. T1 is less than T2. Then, mark a line represent activation energy, EA. The molecule after the EA have enough kinetic energy to react. The shaded area below the curve represent number of molecules that have kinetic energy greater or equal to activation energy. For the explanation, as the temperature increases, more molecules move at higher speed, or kinetic energy of molecules increases. More molecules have energy greater or equal activation energy EA. The number of effective collision increase, thus the reaction rate increases.